Good morning. Welcome to another lesson today. We're talking about lesson 3.3. But first, our quote of the day is learning mathematics is about looking at what you thought you understood and seeing that there's a deeper mystery than you realized. On today's agenda, we're going to solve a system of equations algebraically using substitution. So first, please click on Joey. Have Joey's going to ask, how you doing today? And when you're ready, we're going to start lesson 3.3. So here is lesson 3.3. We're going to be solving a system using substitution. First off, I want to talk about this as a warm-up. If x equals 3 and y minus x equals 5, what is the value of y? I want you to think about how you would solve that. If x is 3, can't I substitute that into x into this equation? So that would be y minus 3 is equal to 5. Then I could add 3 to both sides, and I'd get y is equal to 8. So that process of taking something and replacing it with something equivalent is called substitution. And that's what we're going to talk about today, but this time we're going to talk about solving systems using substitution, not just solving an equation. So the other day we talked about solving a system graphically. Now we're going to solve one algebraically. And our goal for solving algebraically is we need to substitute one of our equations into the other before we can solve. So let's start with this one as example 1. We're going to determine first off if we need to solve for a variable. So looking at my two equations here, one of my equations is already written very nicely as y equals. So because it's already written as y equals or x equals, I do not have to solve for a variable. I'm all set for this equation. Next, I'm going to substitute my expression into the equation for the variable. So this one says y equals 6x minus 11. So that means that where I see a y in my second equation, I'm going to put in 6x minus 11. So I'm going to rewrite my second equation. But now I'm going to substitute, again, using parentheses every time I substitute. 6x minus 11 where that y was. Now, so that's step 2. Check. Step 3 says I need to solve my equation. So looking at this equation, the way that I would start to solve would be to distribute -3 to both terms here. So -2x minus 18x plus 33. Now to solve, I'm going to combine my like terms. My x's can combine. I get -20x plus 33 equals -7. Still solving, I'm going to subtract 33 from both sides. I get -20x equals -40. Divide by -20. And I get x equals +2. Solved my equation. Now what I'm going to do is I'm going to substitute into one of the original equations and solve for y. Usually when I look at this, I like to pick the one that looks nicer. And to me, the one that looks nicer is the first one here. So I'm going to write y equals 6x minus 11, and I'm going to substitute 2, where I see x. 6 times 2 is 12 minus 11 is 1. So now I have a value for x and a value for y. So I'm going to state my equation as my x coordinate followed by my y coordinate. And step 6 is to check your answer. You can always check graphically using your graphing calculator. So in your graphing calculator, one of your y equals equations would be that 6x minus 11. The other one you would need to move around so that it said y equals before you could put it into the graphing calculator. To move it around, I'm going to add 2x to both sides. I would get negative 3y is equal to 2x minus 7. Divide by negative 3. And I get y equals negative 2/3 x minus or plus 7 over 3 because it's a minus over a minus, which gives me a plus. If I type both of these equations into my graphing calculator, those lines should cross at the point 2, 1. Now we're going to move on to example 2. For this problem, it says step 1, we need to determine if we need to solve for a variable. So looking here at my equations, I do not have something that says x equals a number. So I'm going to have to move around one of those equations so that it says x or y equals. So I'm going to look at this second equation because if I add 2y to both sides, I can very easily get the equation x equals 2y plus 11. Now that I have x equal to something, I'm going to substitute into my equation for my variable. So looking at the first equation, negative 7x minus 2y equals negative 13. I'm going to substitute my value for x right into that equation. And now we're going to start solving. Again, I'm going to distribute negative 14y minus 77 minus 2y equals negative 13. Combine your like terms. Negative 16y minus 77 equals negative 13. Add 77 to both sides. When you add that, you get negative 16y equals 64. And now to solve for y, I divide both sides by 16. And I get y is equal to negative 4. Solved. Now I need to substitute that value into one of my original equations to solve for my other variable. So let's look at one of these original equations. Which one looks better? Probably the second one. So I'm going to copy down the second equation. Oops, that was a minus. And I'm going to substitute negative 4 for y. Negative 2 times negative 4 is a positive 8. To solve for x, I subtract 8 from both sides, and I get x equals 3. So that means that the solution is the point 3, -4, because it goes x value followed by your y value. Then we should check in both of our equations to see if it works out, if we're correct. And again, I usually like to do this graphically. However, in this case, it might be easier to substitute. So let's look at substituting for this one. Our first equation, -7x minus 2y equals -13. And I'm just going to take my values for x and y and substitute them in. -7 times 3 minus 2 times -4 equals -13. Let's see. I can say that -7 times 3 is -21 plus 8 equals -13. -21 plus 8 is in fact -13. So that means that the first equation is true. So now we're going to write our second equation, x minus 2y equals 11. And I'm going to substitute in my x and my y values, 3 and -4. 3 plus 8 equals 11. 11 equals 11. So our solution is correct. Depending on the question, it might be easier to graph, or it might be easier just to substitute in using algebra like I just did now.